Today we are going to construct the points of concurrency of a triangle. To be concurrent is to have three or more lines intersect at a single point called the point of concurrency. The 4 points of concurrency in a triangle is the incenter, which is the point of concurrency of angle bisectors, which bisect the angle. The circumcensor, which is the point of concurrency of perpendicular bisectors that bisect the segment perpendicularly. The orthocenter, which is the point of concurrency of altitudes, which go from the vertice to a 90-degree angle on the opposite side. And the centroid, which is the point of concurrency of the medians, which go from the vertices to bisect the opposite segment. To begin construction, you must first construct a triangle. We are going to start with constructing an acute triangle. You use a straight edge and a pencil and construct a scaling triangle that has acute angles. Like that. We are going to start with constructing the incenter, which is the point of concurrency of the angle bisectors. To construct an angle bisector, you will first put the pointy part of the compass on the vertice and then draw an arc on both sides of the angle. Once that is complete, you put your pointy part on the arc that you had created and draw 2 arcs that will cross each other at an X. Then you use your straight edge and draw a line from the vertice to the X, therefore creating your angle bisector. Now repeat this step to construct the other 2 angle bisectors. You will notice that the 3 angle bisectors meet in the middle of the triangle at a point of concurrency called the incenter. Next, we are going to construct the circumcenter, which is made up of the point of concurrency of the perpendicular bisectors. To construct a perpendicular bisector, you will need to place the pointy part of your compass on the vertex and then draw arcs on either side of the line you're trying to perpendicularly bisect. Then you will stick the pointy part of the compass on the other angle and repeat this step. Next, you will take your straight edge and match up the 2 X's with a line in between This is your perpendicular bisector of this one side. You will repeat this step on the other two lines. Please note that when you are constructing the perpendicular bisector, your compass needs to be longer than half the length of the side. Also, don't forget to draw your markings to show that they are perpendicular or bisect the angle or the segment. The point of concurrency that these lines produce is called the circumcenter. The next point of concurrency we are going to construct is the orthocenter. We only have two more points of concurrency to construct. The orthocenter is the point of concurrency for the altitudes. To construct altitudes, you may need to extend the side opposite of the angle that you are using to construct the altitude to find the 90-degree angle that a line will use to go through the vertex. To construct an altitude, you will put the pointing part of your compass on the vertex that you want to start the altitude from. Then draw arcs on the opposite side to make a line segment. Once you have made the line segment, you will find the perpendicular bisector of this line segment so that you will form a 90-degree angle on this line. Once you have found the perpendicular bisector, you will form a line from the vertex through both of the arcs that you have created to form the altitude. You will repeat this step on the other two vertices. Remember, you do not need to draw the full arc every time you are using the perpendicular bisectors. the less arcs you make, the less extra lines are on your construction. The point of concurrency made by the altitudes is called the orthocenter. To construct the final point of concurrency, the centroid, you need to construct three medians. To construct a median, you first find the midpoint of the opposite side that you want to use as your point. To do this, you set your protractor at the vertex of the angle and draw your arcs from both sides. Remember that the compass must be larger than half of the length of the line. Once you have found the midpoint, you draw a line from the midpoint to the vertex. You now repeat this step 2 other times. Three medians meet at a point of concurrency called the centroid. You will notice that the centroid, the orthocenter, and the circumcenter will line up in a straight line. This line is called the Euler line. You will also notice that these three have a relationship. The relationship from the orthocenter to the centroid would be 2x in comparison to the ratio of from the centroid to the circumcenter, which would only be x. Therefore, the Euler line segment has the ratio with the centroid in the center to where the distance from the centroid to the orthocenter is twice the distance from the centroid to the circumcenter. This is true in all triangles. This has been construction on an acute scaling triangle by Nichole Donofrio from Miss Choi's GT Geometry class.